Hello, welcome back to Piers Rocks. This time around, I thought we'd take a look at this second 1571 disk drive after my success in fixing the first one. Let's see if I can make it two in a row. So the symptoms this drive's showing are when you plug it in and turn it on, you don't get a power LED at the front, and the transformer seems to be humming and vibrating in there. That suggests to me that there's a short circuit somewhere in the disk drive, and that's causing the transformer to generate a lot of power. So we'll take the lid off and we'll see if we can figure out where all that power's going. We'll power it on, check it's still exhibiting the same symptoms. Yeah, there's a definite hum coming from the transformer and not seeing any lights on the front. Next thing I'll do is I'm going to remove this plug here, which goes from the main power board over to the logic PCB, to see if we can narrow down the short to either this power board or the logic PCB. Right, I've removed the power cable to the logic board. I turn it on and I'm no longer getting the transformer vibrating. So let's see what voltages we have where. Right, so we have the fluke. So I'm guessing red is 5 volts. It is. So brown must be 12 volts. It is. Excellent. Right, next thing we can do is we can find out where the short is on the logic board, whether it's on the 5 volt rail or the 12 volt rail. Probably should have done that with the power off. The transformer started humming as soon as I connected it, and I don't want to leave it on more than necessary when it's short circuiting like this. So let's have a look to see whether we get 5 volts when it's plugged into the logic board and turned on. We do. Now let's see if we get 12 volts. No. So the short's on the 12 volt line. Next thing I'll do is I will take this disk drive apart so we can actually access the logic board and see if we can see any problems. I thought it would be worth just powering it on without the drive mechanism in place to see whether we still have the short circuit. No, there's no hum coming from the transformer now, so seems like the problem must be with the drive mechanism. I've put everything back together except the read-write heads for this drive, and I'll turn it on. I'm not getting any hum. We can see the power light illuminated, the drive light came on temporarily, the motor did not spin on the drive, and we have 12 volts on a 12 volt line. So that suggests we have a problem with the read-write heads, where a coil on the read-write head is shorted, which is a bit sad if that's the case, because this drive will not work, or at least one of the two read-write heads won't work. I have the drive mechanism in front of me, and I'm going to test the resistances of the coils on the read-write heads. I'm assuming, by the looks of it, that there's two cables. I assume one comes in from the top head, one comes in from the bottom head, and I'm assuming other than that it's very much like a 1541, which means that should be connected, then we skip one, and then the other three should be connected, and we get between 11 and 32 ohms between all of the pairs. So let's check that. That is open as I'd expect. That is hard to probe. 19, 10, 20, 20, 10, These are quite fiddly to probe. 11. Okay, those all look good. If I go to the other side, I get open, which is odd. Open. Open. 20. No, I think it's just hard to make a contact with these. 10. 10. See if I can get a connection to this first pin. No, I seem to be getting open on that one. So I'm getting open between this and every other line. Is that also a point I can probe? Up here. Yeah, so certainly I seem to have a duff read write head. I feel like I should explain what I was doing when I was testing the resistances of the read write and erase heads of this disk drive. So if you look in the service manual for a Commodore disk drive, this is actually from the 1541 service manual because I couldn't find the resistance values in the 1571 service manual, but I'm assuming they'll be pretty similar. You'll find this page. This page shows you the resistances of all the various coils in the motors and also the read-write heads of the disk drive. We can see the read-write heads appearing here. So if you test between every single pair of wires, you'll get different resistances, anywhere from about 10 ohms up to 32 ohms. Depends precisely on the manufacturer of the heads and which pair you're measuring, but between every single pair of wires, all of red, blue, yellow and white, you should get a fairly low resistance. If you get high resistance, then you've got a break somewhere in that wire, either externally or internally within the heads. I was finding open line when I tested between red and everything else, so it suggests that the red wire has broken somewhere. So the red connection on one of the heads is not connected, which will mean it won't work. I'm not sure why we're getting a dead short on the disk drive with these read-write heads. I'm actually just going to put it back together again, including plugging in the read-write heads again. Everything we plug back, and I'll just make sure that I'm getting that short circuit and it's not magically disappeared. I have everything back together. Let's see if we've got a dead short again. No. The dead short's cleared. Let's just double check that I'm getting 12 volts. Volts and 5 volts. Interestingly, we're not getting a power LED out of this drive. Let's just see if it comes on and goes out. No. Well, that's interesting. Okay, maybe it wasn't connected properly because we're now getting the power LED. So one of those two read-write heads has broken. One of the lines is open circuit. What I think I'll do now is I will hook this up to a Commodore 64 and see if the Commodore 64 can talk to it. That's the first test. The next thing I'll do is try speed check or alignment check, and that will test which of the two read-write heads is working. Well, it will test whether the first one is working, the one that reads the first side of the disk, which is the underside of the disk in a Commodore disk drive. And if that works, then it's presumably the other head that's broken, and we can check that by doing a 1571 format of the disk, in which case we should get 1328 blocks, I think. Okay, so we can communicate with the drive, but I'm not expecting anything else to work, as the spindle motor is not turning. We discovered that previously. Just to prove that it's not working, do a speed check. Just get an error straight away. It's because the motor is not turning. So we will need to diagnose that problem next. Good morning. It's a new day, and I decided to print out the 1571 service manual, and I've got the schematic sitting in front of me, and I think I figured out why the spindle motor is not turning, and that might also be why we saw the dead short initially when we turned on the unit. I was looking at this connector here. Let's get a pointy thing. This connector here, which is the control for the spindle motor. So there are 3 lines on there. We have ground, we have 12 volts, and we have a signal that is controlled by one of the VIA chips, one of the 6522 chips. And I checked, this is the way round the connector was connected when I opened up the disk drive, but I think this is the wrong way round, because I removed this. The disk drive's off at the moment, and then I took my multimeter and I tested each of the pins against ground, and that one isn't grounded, neither is that one, but that one is. And we saw the black wire from this connector was plugged in to this pin here, not to this pin. So I'm pretty sure that this is the wrong way around. So let's reconnect it the right way around, and then let's turn on our very sketchy disk drive, making sure I don't stick my fingers in this bit, and we'll see if the spindle motor comes on, turns briefly, and then stops. It did. I heard it. I don't know if you will have heard it. I'll just do that again. In fact, I can see the spindle motor turning. Let me see if I can get that on camera. Okay, so the spindle motor is in here. Turn it on. Round it goes, and that comes to a stop. Turn it off, it will briefly spin again, and then it starts coming to a stop. So we fixed the spindle motor problem. So I'm going to partially reassemble this drive and reconnect it back to the Commodore 64 and see if I get any better success trying to do a speed test. Drive reassembled. Let's turn on the Commodore 64. Spindle motor span. Let's try a speed test. This will fail because there's no disk in the drive. Let's see what happens. Still getting an error. As the read-write head wasn't moving and it wasn't working, I double-checked the other connectors on the PCB, and what do you know, both the other connectors to the drive mechanism were inserted the wrong way round. I figured this out just by looking at the insides of another 1571 on Google. And so those 2 connectors are, one is for the stepper motor and the other one is for the sensor LEDs, like the track 0 sensor and the read-write sensor. So let's try it again. Okay, this is the disk I formatted in the other 1571 mode, so it's a double-sided disk. So clearly it still hit a problem, and we're getting a different read error now, but I saw the read-write heads move. So on that basis, I'm going to do a speed test on this device. Right, let's start off with a speed test. Well, that didn't sound good. That made a very nasty noise when it tried to do that speed check. So this is suggesting to me that the failed read-write head that I discovered when I checked the resistances is the lower one, because that's what this speed test will be attempting to use. We'll just try an alignment check as well. So I don't know what to make of this. For the most part, these look like nonsensical values, although we now seem to be seeing the drive reading a track 1 or 2 ahead of where it should be on the disk, so perhaps the read-write heads are just significantly out of alignment. Yeah, this is the broken one, so it's the lower read-write head that has broken. Now, I can verify that, I think, by plugging this connector back into the main PCB, but lifted up so that the read-write head that's connected on the bottom of the connector here, which is the top read-write head, is plugged in to the top, which is where the bottom read-write head connects into the PCB up here. Then I should be able to see if this read-write head is working by trying to format a disk and read it. I won't be able to read a disk that's been formatted and written by another drive, because from the perspective of this top read-write head, the disk will be going around in the wrong direction, because the disk only spins in a single direction. I don't know if it's that direction or the other direction, but let's say it's that direction that the disk spins in. Then it'll be going backwards. So I won't be able to but I shouldn't be able to because it's going backwards, I won't be able to read a disk that's been written by a drive going in the proper direction. But I should be able to write a disk and read it back going in the wrong direction, because the disk drive shouldn't care, shouldn't notice the difference. This setup is getting sketchier and sketchier. Let's try formatting a disk. The drive should be in 1541 mode at the moment, so should only try and format it on the one side. And as a reminder, that should be using the read-write heads that tested OK. Okay, I'm seeing the read-write heads move normally across the disk, and I can see down here that the activity light is solid on. Ready, and the activity light has gone out, so we should have no error. Let's load the directory of the disk. So that formatted OK, but as a reminder, this disk won't read in any other drive because it's been written backwards. But that's confirmed my suspicion that the top read-write head is working fine, and it's the bottom read-write head that has failed in some way. Obviously the PCB electronics associated with the bottom read-write head are fine, so it must be a problem in a mechanism or a read-write head itself, and the only thing there is the read-write head. I mean, the connector goes directly to the head itself. So I really need to dismantle this drive mechanism further so I can see the bottom read-write head and see if the cables have broken as they go into the head. There's not much I can do if there's a problem within the head itself, but if there's a break, say, somewhere in the cable between where it connects into the PCB and the read-write head itself, then I might be able to repair it. Right, I have the read-write head mechanism removed from the drive now. As a note, I'm not actually sure I should have removed it this way. I've taken this plastic carrier unit off the metal belt that drives the head backwards and forwards, and that was held on with some epoxy. It wasn't in very good state, but I may have to re-glue that when putting it back together, or this carrier may jiggle backwards and forwards and therefore not be well aligned. I've just toned out between each of these connectors on the lower read-write head and the traces on this flexible connector here, and there's continuity, so there's no break between here and here, which is a bit sad because that suggests that the break must actually be either where this flexible connector goes into the head or within the head itself, and I think it's beyond my wit to repair that. So at this point I'm at a bit of a loss. I don't really know that there's anything I can do to recover this disk drive. Obviously the top read-write head is still working, so if I subsequently get a unit with a bad top head and a good bottom head, then I can use this as a spare, and I can use the rest of this drive mechanism as a spare and the rest of the 1571 as a spare, but I don't think there's anything else usefully I can do with this, which is a shame. Well, there you go. This time the repair was beyond me. Certainly repairing a broken read-write head for one of these disk drives is not something I've seen done online. But the only thing you can do in this situation is replace the broken head with an assembly from a working unit, like this one. Now, I'm not going to go about cannibalizing this 1571 to fix this one, since this one down here is in much better condition than this second unit. But all's not lost. I learned a whole bunch of stuff about the 1571 during this process. I also have a whole bunch of good parts in this drive. Other than the read-write heads, everything else on this disk drive seems to be working well. So if I get another 1571 at some point in the future which needs some replacement parts other than a read-write head, then I'm in good shape. Anyway, I hope you enjoyed this video. If you did, please do consider subscribing. Until next time, rock on.